Okay, I knew we were running out of time. So now we're on number 11. Okay, find the sum of the first four terms of the geometric sequence below. So we're still dealing with a geometric sequence. It's going to have a little different ratio. Definitely going to be a fraction. So I think we're dividing by 5. That's what it looks like we're doing. Okay, so we're going to find the sum of the first four terms. The first term of my sequence is 4. 1 minus common ratio. Look what's going on here. It looks like we start with 4 and then we go to 4/5. So it looks like we divided by 5. And whenever you divide with a ratio, that means instead of listing it as dividing by 5, we always list it as a fraction. Whenever you're dividing, your ratio is a fraction. The 1 goes on top, and whatever you're dividing by goes on bottom. And then it looks like we divided by 5 again, or multiplied by 1/5, because the 4 stays the same and the bottom changes to 25. So my common ratio is going to be 1/5. I raise it to the 4th power. This is going to be a great one for Desmos. Okay, so let's go to Desmos here. I'm going to just go to my Desmos calculator. I love me some Desmos. Super helpful, desmos.com. Lets you type it in. Okay, so here's the fraction. I'm going to do that part first. Oops, not that. 4. Oh, it's being difficult there. Okay. 4, where's my parentheses? 1 minus 1/5. And then I need to raise that. Oh, not to the 2. To the 4. Okay. Then on the bottom, I'm going to put 1 minus fraction 1/5. And check it out. Look what's here. I'm going to erase this formula. It's going to tell me this decimal, but Desmos is awesome because all you got to do, bam. So I don't know if they want decimal or fraction. So we're going to give them both. 624 over 125. And then let's hit it again. 4.992. Okay. So then we'll go back to, oh, the homework is down here. Okay, so we're going to enter in, it looks like probably a fraction. So let's enter it as a fraction. 624 over 125. Check answer, and it's correct. So if you don't like the problem that you're given, just use Desmos or the numbers. If it's just weird numbers, you can, even if it's good numbers, you can use Desmos. Okay, so this one's an infinite geometric series. So this one's going to be a little bit of a different formula. So they want us to find the sum of the terms of the following infinite geometric series. So we're going to go to question help and view an example to get that formula. So here it tells us the formula is right here. The sum of an infinite geometric series is the first term of the series over 1 minus the common ratio. Okay? So we're going to plug that in. So it looks like, look what's going on here. We start at 36 and then we divide by 7. So since we're dividing, we know our ratio is going to be a fraction, and it looks like we divide by 7. And we can test that because if your ratio is 1/7, dividing by 7 is the same as multiplying by 1/7. We can take 36 over 7 and multiply by that common ratio, and it does give you 36 over 49. So let's put it into our formula. So our first term is 36, And our common ratio is 1/7. And let's plug it into Desmos. Why not, right? We already have it kind of good to go. So we're going to go fraction first, 36 over 1 minus 1/7. And you get 42. 42 is going to be our sum here. Kind of crazy if we started with like infinity and it's just 42. All right. Oh, have I been doing the evens? Oh my gosh, you guys. I'm so sorry. Let's see. What did I do? Jen. Okay. So let's get back on track. You guys just do the same thing I do. You do question 11 and 12, and then we'll skip ahead to 15. Okay. Modern car company has come out with a new car model. Market analysts predict that 3,000 cars will be sold in the first month and that sales will drop by 70 cars per month. During the year, write out the first 5 terms of this sequence and find the number of sold cars predicted for the 12th month. Okay, so the first 5 terms, so it looks like we're going to start at 3,000 cars and they're going to drop by 70 cars per month. So the first 5 terms, so we would drop 70 every time. So that means I'm going to use my phone calculator here just to not write a bunch of junk all over. Okay, so 3,000 minus 70, that's going to give us 2,930. Then we're going to minus 70 again. That gives us 2,860 minus 70 again. That gives us 2,790 minus 70. That gives us 2,720. So those are the first 5 terms of the sequence. So 3,000, comma, 2,930, comma, 2,860, comma, 2,790, comma, 2,720. Correct. Yay. Okay. Now they want the number of cars predicted for the 12th month. So here's what you could do here. You could, honestly, I think it's easier just to keep subtracting 70, right? So this is 5 months. 6, 7, 8, 9, 10, 11, 12. So we're going to have to subtract 70 7 times. You could come up with this crazy sequence, but I don't know. I think this is easier. I really do. 2,720 minus 70. So there's 1 time, 2nd time, 3rd time, 4th time, 5th time, 6th time, 7th time. So we are left with 2,230. I think in this case it's just quicker to just use your calculator. Watch, I'm wrong now. Hey, I'm not. Okay, the total predicted number of sold cars for the year. So now they want the sum of the series. And remember, that's that formula. I forgot what that is. 230. So I gotta look up the formula again. Silly me. We keep writing it out. So I'm gonna go to question help and view an example. I just need the formula. Continue, continue, continue. Okay, here's the formula. Now we want the sum formula. Come on. There we go. So, oh, and it's for an arithmetic sequence. So since we are just subtracting, what you would do is you would type into Google partial sum formula for arithmetic sequence. It's just a different formula. So we would take n, so we want the sum at the end of 12